This is our solar tracking assembly. We have our servo motor here. This is our assembly just to hold things together. Our solar panel, little motor here, a little bit of tape there to show you when it operates. This here will be our light dependent resistor, is down this tube here that detects darkness, and this one here detects whether it's daylight or not. So let's see how it operates. At the moment it's pointing, we have the dark LDR pointing towards, if you like, the shade, and our light source is coming from this direction, the window. So if we turn it on, we see it tracking towards the light, and then once it reaches the light, it stops. Now what we could do is maybe rotate it away from the light, and we'd see that it keeps tracking back, in the same way as the sun travels east to west across the sky. Now if we cover the darkness LDR, it's going to track all the way through 180 degrees and then return to base, if you like, which would be the start of the next day, if you like. So it tracks around from east to west, and then when the sun sets at west, it'll rotate back towards the east. Now if we cover the daylight detecting LDR, it thinks it's nighttime, so there's no point in it tracking any sun, so it doesn't move. If we remove it and expose it to daylight, well then again it's going to track the sun as before. We'll have a little look at the electronics part of it. This is our Arduino, and this is our breadboard. This side here is our dark detecting voltage divider connected to the dark reading LDR, and this is our light side voltage divider connecting to our light detecting or daylight detecting LDR. The usual jumble of wires, hard to follow it. I'll do a circuit diagram and show you that properly later. This is the circuit diagram. On the left is the Arduino, and this is the shade detecting LDR voltage divider circuit connected to pin 8 on Arduino. On the right, the daylight detecting LDR voltage divider circuit connected to pin 7 on Arduino. As you can see, we are taking 5 volts from the Arduino, and this is running the servo motor, which is connected to pin 9 on Arduino. We'll look later at how the voltage divider circuit works with Arduino. Here we have the code for Arduino. First, a brief explanation of how the servo motor moves. If I tell it to move 90 degrees, it moves to a position 90 degrees anti-clockwise from its rest position. However, the sun moves east to west, that is clockwise rotation. So what I do in the code below is move the servo 180 degrees anti-clockwise and point the shade detecting LDR east. Then, as the LDR tracks the sun, I move the servo back from 180 degrees by minus increments so that the servo motor is moving in a clockwise direction. Okay, now the code. POSINC sets up the incremental movement of the servo to be 15 degrees. New pos equal to 180 tells the code below that we are starting at 180 degrees. The myServoWrite 180 sends a signal to the servo to rotate 180. This rotates it anti-clockwise to phase east at the start of cycle. That is the start of the day. Pins 7 and 8 are digital input from the LDR circuits, and pin 9 is the output to control the servo. When we start the loop, the first thing to check is if we have daylight. When it is daylight, the output from the daylight detecting LDR to pin 7 is around 3 volts, which Arduino sees as high, in other words greater than 2 volts. And if it's not daylight, the rest of the code doesn't proceed. What next? First, we skip down to the if digital read 8 loop. What's happening here? The initial value for new pos is 180 degrees. Now, if the light source, the sun, moves away from the shade detecting LDR, the voltage output would be around 2.5 volts. And Arduino will see this as high at pin 8. So new pos is 180 degrees minus 15, which is 165. So the servo moves clockwise 15 degrees, and so on until the shade detecting LDR is pointing at the light source again, and pin 8 is no longer high, and so new pos doesn't change until the sun moves away sufficiently to cause shade again, and so on until the end of the day when the shade LDR is now facing west, thus new pos is 0. If we look at the if new pos equal to 0 loop above, this will have a yes for new pos equal to 0, and so we return the servo to 180 degrees facing east for the next day, and a new cycle will begin. This is the solar panel operating. As you can see, it's rotating the motor in full sun. My next project is to present a hardware solution to the solar panel tracker. I will use a DC motor, relays and reed switches activated by magnets, without the need for Arduino. The end screen shown is a link to a video with a more detailed explanation of how the LDR voltage divider circuits work for detecting daylight and shade.